Hi there, this is the review worksheet for Arithmetic Geometric Series and Infinite Geometric Series. As always, I am the amazing Mr. Jansen, so away we go. If we look at the first one, it's asking us to find the sum of the series, and so really the first thing we need to decide is what formula I'm going to be using. So I look at this thing and decide, is it arithmetic or geometric? And the pattern here is that I'm subtracting 4 each time. In other words, I'm adding a -4. So since I'm adding the same thing each time, I know it's arithmetic, which means I'm using this formula. This is the formula for the sum of an arithmetic series. So I do S sub n equals n over 2. And I don't know what n is. I don't know how many terms are written here. This ... means there could be 100 terms in between there. There could be 2 terms in between there. I don't know. Times a sub 1, which is the first term. That's the 64. Plus a sub n, which is the last term essentially, which is the -72. And so what I need is I need that n value. So yeah, I have to use my other arithmetic formula to find the n value. So I'm going to use this one now to find that n value. Okay. I already know what a sub n is. That's my -72. I already plugged that in as a sub n in my other formula. Equals a sub 1, which was the 64, plus n minus 1 times d. And d was the thing I was adding each time, which was the -4. And so now I want to solve this. I'll do it this way. I'll distribute the -4. So that's a -72 equals 64 minus 4n plus 4. And then I'm going to combine like terms, the 64 and the 4. Oh, I got a little messy over there. Let me try that again. So I get a -72 equals 68 minus 4n. And now I subtract the 64 from or the 68 from each side. That gives me a -140 equals a -4n. I divide each side by the -4. And I do all of this just to find my n value. So I find out that n is 35. Now I can finish finding the sum, because now I know that I'm looking for the sum to the first 35 terms. So in other words, I know what my n value is. And now this becomes a job for my calculator. So I'm just going to plug this in. And when I do that, it looks like it gives me a -140. So it's all about choosing the right formula, plugging in what we know, and if I'm missing something, I just go back to one of my other formulas to find that thing that I was missing. Okay? If I look at the next one, again, I'm looking at the pattern here, and I see that the pattern is that I'm multiplying by 2 each time. So since I'm multiplying by the same thing each time, it means this one is geometric, and I want to find the sum of a geometric formula here, so I'm going to use this guy. That's my sum for a geometric series. That's S sub n equals a sub 1, which is a 2, times 1 minus r. R is the thing I'm multiplying by, which was the 2. N is 15. It says right here that I'm going to the first 15 terms. All over 1 minus r, which again is the 2. And this is, once again, just a job for my calculator. We just have to be careful as we plug this in. I'm going to go ahead and show it step by step to show the order of operations. So I do 2 to the 15th power, so that's 1 minus 3 to this guy, all over 1 minus 2. And then after I do that, that's going to give me, and sorry, I suppose I could say that I'm looking for S sub 15 here, since I'm looking for the sum of the first 15 terms. But as I do this, now I'm going to subtract what's inside the parentheses. That's going to give me a negative, all over 1 minus 2, which is a -1. And now I do some multiplying. This I can probably skip to the end. I do a little bit of multiplying and dividing. So I get this, 32,700. Sorry. And yeah, 69. And that's about it. Okay. So again, I'm just plugging this in. Oh, I forgot to multiply this. Sorry, I hit the addition button on my calculator instead of the multiplication button. So I get this, 65,534. And that's it. So just be careful plugging this thing into the calculator. It's easy to make a mistake. If I take a look at the next one, again, I'm just identifying what kind of series this is. This one is geometric. I'm multiplying by 1/2 each time. So I use my geometric sum formula. That's S sub n equals a sub 1, which is the 64, times 1 minus r, which is 1/2 this time, raised to the n. Except this time I don't know what n equals. So because I don't know what n equals, it means I need my other geometric formula, which was the a sub n. This time a sub n is the 1. It's this last term that's hanging out over here. Equals a sub 1, which is the 64, times r, which is 1/2 raised to the n minus 1. And now I just want to solve this thing, so I divide each side by the 64. Again, I'm only using this formula because when I tried my sum formula, I was missing something. Anytime we're missing something, it means I have to go to my other formula and solve for what's missing. And so here I want to write these so they have the same base. 64 is the same thing as 2 to the 6th power. So that means that 1 over 64 is 1/2 to the 6th power. So I rewrite that guy, equals 1/2 to the n minus 1. And now that I have the same base, I can set the exponents equal to each other. In other words, the n minus 1 equals 6. And I can add that 1 to each side. And I find out that the n value here that I was looking for is a 7. So now I can come back over to my formula. I know that I'm looking for s sub 7. Got the 64. Again, 1 minus the 1/2 raised to the 7th power now. All over 1 minus 1/2, which I'm going to simplify right now and just say that's 1/2. Okay. So again, I just want to plug this into my calculator. 1/2 to the 7th power gives me a 1 over 128. And then when I do, when I subtract the 1, that's 127 over the 128. And when I multiply all this out, that's going to give me a 127. Okay? So again, just be careful plugging this thing into the calculator. Do it in a couple steps if you need to. Okay? If I take a look at the next one, again, I look at the pattern here. I'm adding 4 each time, so I know this is arithmetic. So I'm going to do s sub n. And this time I know what n is. I know that it's 15, so I'm really looking for s sub 15 equals my n value, which was the 15, over 2 times a sub 1, which is a negative 3, plus a sub n. And that's the thing that I'm missing here. I'm talking about the last term. The last term, I don't know what it is, so I have to use my other formula. So right here, I go to my other formula, a sub n, which is what I'm looking for, or a sub 15 this time, equals a sub 1 plus n, which is 15, minus 1 times d, the thing I'm adding each time, which is the 4. And really, this is just a plug it into my calculator type of problem. So that gives me a 53. And now I can come back over here and I can fill in this blank, the thing I was missing here, that 53. I fill that guy in, and now I can plug this thing into my calculator. It looks like I get 375, and that's it. All right, so I use the sum formula. I'm missing a piece. I go back and use my other formula to find it. All right. For these, remember with sigma notation or summation notation, this is my starting value down here. This is my stopping value. So I start by plugging in a 1. When I plug in a 1, I get a negative 2. And then I plug a 2 in. That gives me a 0. I plug a 3 in. That gives me a 2. I plug a 4 in. That gives me a 4. And I would keep going until I plug in a 100. When I plug in a 100, I get a 196. All right. And so one way to do this is to literally plug in all 100 values and then add them all up. I kind of skipped around in there, but now I know that I started here. This is the first term, and I know this is the 100th term. And so when I look at this thing, I can see that what I'm doing is I'm adding 2 each time. So I've got an arithmetic series. So I can just use my formula for an arithmetic series. I know that there's going to be 100 values here, even though I didn't write all of them out. So I know my n value is 100. I will have 100 values if I wrote them all out. I know the first term was the negative 2, that's a sub 1, and I know the last term, the 196, which is my a sub n. Okay, so I just start writing this thing out, and I should see that it's very similar to the first problem from this worksheet. and then I can go from there. So now I've got the 194 times the 100 and divided by the 2. And it looks like the sum here is 9,700. And that's it. If I look at this one, this is the same thing. I've got my starting value down here, and I've got my stopping value up here. So I start by plugging a 1 in. So I plug a 1 into this thing, and that gives me a 2. And then I plug a 2 in, so plus, and then I plug a 2 in. And just be careful when you plug these values in, especially with the negative. If you plug a 2 in here, you've got negative 2 to the first power, and then times the 2. Make sure you follow order of operations. That's a negative 2, and then times a 2, which is a negative 4. Okay. Same thing with the next one. When I plug a 3 in here, I'm going to have 2 times a negative 2 to the second power. And just be aware, I'm going to do this piece first right here. So I do negative 2 in parentheses to the second power is 4, then times the 2, which is 8. All right. I do the same thing with the next value. So I plug the next value in, I get a negative 16. I plug the next value in, I get a 32. And that's my fifth value. See, I plugged in a 1. Then a 2, then a 3, then a 4, then a 5, and that's where I stop because that's the stopping value. Okay, so now I'm just going to add all of these together. So when I do that, let's see, it looks like I've got a 16 plus 4 plus 2, so it looks like a 22 here. Okay, and that's it. And again, the reason I didn't write this down and do it like I did the previous problem is because I only had 5 terms to find, so I just plugged them all in and I found them and I added them together. When I have like 100 terms, that's when I want to break off and go to one of my formulas. Okay?